last part of this problem, it's a nice transformation question. We haven't seen one of these in a while, so let's do it together. So this is telling us that the graph of the composite function g of f of x can be obtained by applying 4 transformations to a good old-fashioned sine of x. So we want to start at sine of x, and we want to do a transformation, 4 different transformations, to get to the composite function 3 sine of 2x plus pi over 5 plus 4. What are those steps? 4 of them. And remember, we have 3 kind of options of transformations that we can do. We can either have a vertical or a horizontal shift, vertical or a horizontal stretch, so that's 1, 2, 3, 4, and a reflection across the x-axis, reflection across the y-axis. We know that there's no reflections taking place here, so we can already discard those, which means literally the 4 ones we have left are the 4 ones we have to apply. And we can see those represented by this number 3, that number 2, that pi over 5, and that 4. The order that we do some of these in is going to be important. So let's keep that in mind while we work through this. The first one that makes the most sense for us to do is to think about this 3 term. The first thing that we're doing here is we're applying a vertical stretch of 3 units, or times 3. That's going to be the very first thing, because that takes the whole sine curve and it compresses it by times 3, or that 3 coefficient. The second step we'll do is, let's keep in mind, so let's keep doing the same kind of direction. So if we do a vertical shift first, let's look at the vertical stretch first. Let's look at the vertical shift. There's a vertical shift of plus 4. Vertical shift of plus 4. Notice how the order is important here. What would have happened? Say if we would have said, oh, we're just going to do a vertical shift of 4 first. So let's say we started off with sine of x, and we did a vertical shift of 4. Then we did a vertical stretch of 3. We would actually be taking this whole function, multiplying it by 3, which would have given us 3 sine of x plus 12. But 12 is not the same as 4. So the order is super important in this case, especially if we're dealing with coefficients, stretches, and constants with the shifts. So I'm going to erase this, and note that we first apply the stretch for the vertical case, then we apply the shift. Now, the vertical stuff is done. Let's talk about the horizontal stuff. Now here, we see that we're only left with the stuff on the inside of the sine. Those are going to be the horizontal shifts and the horizontal stretches. We're first going to apply a horizontal stretch. Horizontal stretch. And remember that these ones are the opposite of what you want. So if the coefficient is 2, it's a horizontal stretch of 1/2. It's going to be, instead of a compression by 2 in the horizontal, or relative to the horizontal axis, it's going to be an expansion, or it's going to be half as wide along the horizontal axis by 1/2. Then the last component of this, that plus pi over 5, is important, but remember, it's not a horizontal shift to the right. It is a horizontal shift minus pi over 5 spaces, or just to be very clear, to the left. Shifts pi over 5 to the left. Same kind of arguments apply for the order of these things. Had we applied the shift first, then had we applied the stretch, we would have had a total stretch of pi over 10 units, which is not the case. We're looking at for a pi over 5. So those should be enough to get us all 4 points for here, and altogether enough to get all 9 marks for this question 9 question for the old IB HL exam.